guys, this is Saral this side. So today we will be covering up one of the most common questions that being put up in interviews or maybe asked in various sessions of Q&A that regarding facade patterns. So it comes under one of the category of structural patterns. So let's start today with facade pattern. Let's start. Okay, so it's a common design pattern in which we try to solve some of the common reoccurring problems like classes in this design patterns are just normal classes if I go into the technical part, but the most important thing is that how they are being structured, all those different classes, and how they can give you a solution at a runtime in one of the best ways. Okay, so the normal objective of introducing facade pattern, it was just to simplify the interface of the complex systems. Like normally what happens when we go to an ATM and when we insert our cards, we see that we have been provided with the different options like withdrawn, or we want to check a balance or something like this. So behind this simple interface of an ATM, there are different services, or maybe I could say the microservices are being deployed and being executing. But ATM is an interface which provides you a simple solution, so it hides all the complexities that are being there at the back end. Okay, so that's what I say, that a facade is a bit of shield to a user. A user doesn't know how the complex details are being at a backend, but a facade always provides a simplified view, which becomes very easy for a user to use and go ahead. So it tries to technically, if I look, it tries to decouple the code that system uses and get the details from the subsystems, make it easier for an end user and for the system being a later part. So this is something where we can see, this is a just short diagram, where we can see that clients are there. In between, there is a simplified layer, which is hiding the complexities of the different subsystems. These subsystems may be technically, maybe different microservices or maybe different independent services. Okay. So as I told you, that it provides you a high level interface that makes other domain functions very easier to use and manage. Okay, the core principles that what I see behind the facade pattern is to provide you the unified interface, as I earlier told you, because sometimes you want to provide a simple interface to the client and you wanted to manage all the complex systems or all the handshakes that is occurring with the different subsystems at a backend. You don't want to expose them. You wanted to introduce, maybe the second thing or a second part, I can say that you wanted to introduce something called a layered approach to your applications. Okay, so at that part also, I can say that facade pattern is something useful. Okay, I told you in the beginning we started out, it's come under the category of one of the structural design patterns where we have to provide a layered and a decoupled structure. Okay, now I told you an ATM example, by the way, and but again, for a bit of high level overview, I will give you one of the examples of the e-commerce applications like Amazon, Flipkarts that we used, or eBay, where you becomes a member and we are registered. We try to log in, we got authenticated, we got authorized to view some pages, and after that we try to add some items. Okay, when we try to add some items into the cart, there are a lot of things happen at a backend. So that's we wanted to see, and how we can apply the facade pattern at that point of time in this example. So this is just a one real life use case examples where we try to see that how we can use this patterns. Okay, so first, if somebody tries to log in into any of the e-commerce website, first we'll try to see that if the request is coming up from the registered customers. Not if it is coming, then we'll show them a pop-up saying that first register to us. Okay, second, we'll see that if product which the customer, if he has been the successful login user, but if the product he is requesting is available in our warehouse or not. Okay, so that has become the second dependency. And third is that if the product is available in the warehouse, then we need to add it to the cart, and then we show to the notification to the customers that okay, this product is being added, such and such price is being available for this product, for how much stocks of this quantity is available, and is there any scheme that or any coupon code that we can apply over this. So these are the if I try to divide this is something, all the different microservices that can be taken care of. That's what I'm saying, that the 3 points which I showed you here right now, they can be all of the 3 different microservices all together. But as a client, you never think of, what complexity of the systems is being running at a backend, or what you need from the backend side. Okay, you are least concerned about thing. What you need is just you wanted to drag an item, you wanted to search the same, or you wanted to add it to the cart. That simply means that client class is expecting an interface from you. Okay, and so if I try to divide them into different layers, maybe decoupling the internal and logic, or the internal subsystems logic, then this could be like, these are the three actors, they want these three services, like adding product, removing, or placing an order. Now here comes our Facade design patterns. So basically these are different subsystems. You can see this is user service, shipping service, payment service, text, place order, inventory, and all these services. These are themselves are decoupled, and they are different subsystems. And this our Facade layer is one of the layer which is interacting, okay, which is interacting with these these different subsystems. That's matters for me. Okay, so these are different subsystems to which these microservices, different microservices are individual microservices, and Facade is one of the layer which is interacting with these different microservices. Okay, now the question comes that how our Facade pattern can help us into decoupling the things, maybe providing us the more managed structures. So this is done by providing the unified interface. Here it was this unified interface. Okay, these are the actors, these are calling the events, and which is landing up into the different subsystems. Okay, so maybe we can have a unified interface like add product to the cart, remove product from the cart, placed an order. So these are the three things that we can at least try to have, these three things. Okay, so that's what I was trying to say. So all these flows needs are different subsystems. Okay, either via compositions or inheritance. It's better to delegate these calls to these different systems. Okay, maybe one call to go to one subsystem, to one service, and another call which is specializations in another service may be delegated to that thing. Okay, so Facade can provide us a unified interface where managed calls happens to the different interface. So this is the again the diagram, the same, the actor. Here we have shown our unified interface should be like this. So this is the calls that is being happening to the different subsystems. So this is just in short of Facade, because this is most of the common questions that being asked. What is a Facade pattern? What advantages does it provide? One of the real life case examples is that you can justify for the same. So this is just very short video, not too long, just to help you guys just to understand the concepts. So thank you for joining. I'll be coming up with such more interesting, nice videos. Thank you guys for this. Thank you.